Okay, for this next lesson, we're going to look at the trigonometric ratios that we learned from last lesson and how they apply on a calculator, as well as the patterns that show up in these ratios. So, we know we have our SOHCAHTOA, which represents our three ratios. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. If I am using a calculator to determine the trigonometric ratios, then we have already up here discovered that the ratio of the opposite over the adjacent is 0.7 for this tan ratio of 35 degrees, and that if we did the opposite over the adjacent, it was 1.6 degrees if it was, 1.6 if it was 58 degrees. If I want a more accurate version of this, I'm actually going to use the tan function on my calculator. So what I'm actually putting into my calculator is tan bracket 35. Now, in order for this to work, your calculator has to be in degree mode. So, if your calculator is not currently in degree mode, what you're going to do is, if you're on a TI 83 or 84, you're going to click the mode button. It is just below, just to the right of the button that says second on your calculator. You're going to scroll down to the third line where it says radian or degree, and you're going to select degree. Make sure it is highlighted, and then when you quit out of there or go second mode, all you're going to put in your calculator is tan 45. The answer should always show up as 1. If you are not currently in the correct version or in the correct mode, if you put tan 45, then your answer is going to be 1.619, which is not correct. If you are doing this on a Casio calculator, then what you're going to do is you're going to hit, for Casio, Shift, and then Menu to go into your setup options. You're going to scroll down to where it says angle, and then you're going to press F1 in order to switch into your degree mode. One thing that I should let you know is if you are on a TI 83 or 84 calculator, if you ever reset your calculator doing the second plus 7, right 1, 2, it will always switch it back into radians mode, so you're always going to have to put it back into degree mode if you're doing a test in school. Alright, so if you have it in the correct mode, then your answer should be 0.7002. Oh, sorry, not 7002. If you have it in the correct mode. If you have it in the wrong mode, your answer is going to be 0.4738, which you should know now is incorrect. So always check your modes. All right, if you put in tan of 58 into your calculator, then the correct answer that you should get is 1.6003. So I'm going to use a calculator to try out all these ones. If I put sine of 35 into my calculator, I get 0.5736. If I put in cos of 35, I get 0.8192. Sine of 58 is 0.8480. And cos of 58 is 0.5299. With respect to the diagrams at the top of the page, which ratio of sides is represented for each of these? Well, if I'm just looking at sine of 35, then that's going to be the side length of AB divided by OB. If I'm doing cos of 35, then from the picture at the top, that would be the side length of AB, sorry, got the wrong one, OA divided by OB. If I'm looking at the 58-degree ones, sine of 58 would be the side lengths of AB divided by OB, and cos of 58 would be the side lengths OA divided by OB in the second picture. The diagrams below show triangles similar to the ones on the previous page in which the two hypotenuses are equal to exactly 1. As the angle of AOB, or the angle at O, increases from 35 to 58, explain using SOHCAHTOA why the sine ratio increases, but the cosine ratio is going to decrease in value, and determine what happens to the sine ratio. So if this side length is staying the same, and we just rotate this same side length upwards, then suddenly what's happening is, in order to keep this exact same length, then this opposite length is getting larger while this is getting shorter. So, how can we state this? Well, if the opposite increases, and the hypotenuse stays the same, then the sine ratio opposite over hypotenuse will increase. If the adjacent decreases, as the hypotenuse stays the same, then the cos ratio of adjacent over hypotenuse will decrease. And finally, if the opposite increases, and the adjacent decreases, then the tan ratio of opposite over adjacent will increase. So that means that if I have a bigger angle, my tan ratio gets bigger. If I have a bigger angle, my sine ratio gets bigger. If I have a bigger angle, my cos ratio gets smaller. So, without using a calculator, state which of the following is going to have a greater value. Well, if I have a sine of 14 and a sine of 20, if my sine gets bigger as my angle gets bigger, then sine 20 is going to be bigger. If I have cos of 7 and cos of 62, well, as my angle gets bigger, my cos ratio gets smaller, then cos of 7 is going to be better. If my tan ratio gets bigger as my angle gets bigger, then tan of 75 is going to be bigger. And in the last case, well, we know it's not going to be cos of 80 because it's going to be a bigger number, so it's either sine or tan, and the answer in this case is going to be tan. Why is it that tan can get bigger? Well, because my opposite can get larger than my adjacent, which means that I can have a tan ratio bigger than the number 1, but my opposite, no matter how big the ratio gets, my opposite will never be bigger than my hypotenuse, which means that my sine can never actually be bigger than 1. So in this case, tan is going to be the biggest one. All right, so if I'm going to use a calculator to determine the value of each ratio to 4 decimal places, well, I'm going to say sine of 81 is going to be 0.9877. Tan of 14 is going to be 0.2493. And cos of 44 is going to be 0.7193. If I need to put this into practice and I need to determine the angle given the ratio, anything that I can do in one direction, mathematically speaking, I can do in the opposite direction. So in this case, if it's saying it wants us to determine what the ratio is, doing a guess and check, well, I could start with like tan of 40 or tan of 50. In this case, it would be 0.8390. That's not even close to this. Tan of 50 is going to be 1.1917. That is definitely closer to what this is. I could say tan of 50.1, and that would give me 1.1960. Well, that looks very close. Tan of 50.2 would give me 1.2002, and that's as close as I'm ever going to get. So this would be tan of 50.2 would be approximately equal to 1.2. But that's a silly way of doing it. If I'm looking for the opposite function in my calculator, what I'm going to do is I'm going to either use second tan or I'm going to use shift tan, depending on which calculator I have, in order to get this tan to the -1 function. This is not the same as tan to the power of -1. Tan -1, sine -1, cos to the -1 is if I tan something, if I tan an angle to get a ratio, then I can tan -1 a ratio to get an angle. And that's where I get that second tan.